Friends, welcome back. Today we are going to solve one very important coding problem. It's on Leetcode 845, longest mountain in array. This is one of the coding questions asked by Google, Facebook, Microsoft as well as many other companies. So make sure you watch this video until end so you can completely understand the logic and the Java solution for this problem. This is a very important coding question, and I'll explain you the logic with a couple of examples. We will go through the problem statement and you will completely understand this problem at the end of the session. So before we start looking the details, I just want to mention that this channel is to help people in their coding and Java interviews. If you are new to this channel, there are over 400 different varieties of problems solved on this channel. Those are the coding interview questions previously asked by Google, Facebook, Amazon, Apple, Microsoft, Yahoo and many other big tech companies. So if you are preparing for your coding interview rounds or Java interview rounds, then this channel can definitely help you in your preparation. So please subscribe to this channel now. Also, whenever I solve any important coding problems, I create videos on this channel so that I can share the solutions and the logic with others so they can benefit by watching those videos. So make sure you click on the bell notification icon right away so you will get immediate notifications. So let's start with the important problem, longest mountain in array. As you can see from like dislike ratio, this is very likable problem and frequently asked coding question. So you may recall that an array is a mountain array if and only if the array length is greater than or equal to 3. And what this mathematical expression they are telling us here, what it says, I'll just explain you that with an example. So if this is the array, let's say, that is given to us, right? So if this is the array, then as you can see, this is one mountain, right? So this is basically, if you consider this sub array, correct? This is one mountain array basically in this. So what does mountain means? Means it is like, you can say that these values are like 1, then 4 and then 7. So it is like increasing basically, right? It reaches the peak. The peak of the mountain is at 7, then it will decrease, like it will go to 3 and 2, right? So what it means is, if I plot a graph, let's say if I plot a graph, right, then for this sub array, correct, then it will look like this basically, right? So this is, let's say, 1, this is 1, then this is 4, then this is 7, then this is 3, then this is 2, right? So it is kind of a mountain it is forming, right? It's like a mountain, right? So this 7 is the peak of that mountain, right? So that's what the mountain array means. So the expression they are saying is, these elements should follow that order, right? So for example, they are in increasing order, then 1 and then 4 and then 7, and after it reaches 7 it goes down, so it is in decreasing order, 3 and 2, right? So this is one mountain array. Is there any other mountain array in this? Yes, there is another mountain array also here. So let me show you that. So this one is the another mountain array, you will see, right? So it will go from 1 2 3 4 5 6 and so it will start, the another mountain array will start at this point, correct? This is another mountain array. So as you can see, this is 2 5 10 20. So 20 is the peak, right? And then it will decrease, right? So 18 16 and 8, correct? So this is also another mountain array. So what the problem is asking us to do is, for the first mountain array that I shown you, the length is 5, right? The length of that mountain array is 5. The second mountain array length is 7. How many elements there? 1 2 3 4 5 6 7, correct? So they are asking us to find out the longest one in these mountain arrays, right? So the longest one here is 7, right? So we have to return 7 as the answer. So this is what the problem is basically that we are solving, right? So because if you this kind of confusing sometimes, so with example it's very easy to understand. So now that's why I explained you with the example. So as you can see, given an integer array, return length of the longest sub array, which is a mountain array, right? Return 0 if there is no mountain sub array. So this is what the problem statement says. So they have given us couple of examples here. So we'll go through those. So constraint says that the array length can be between 1 and 10 raised to 4. So 10 raised to 4 means 10,000, right? So maximum 10,000 elements will be there in the array. And the element, the number in the array can be between 0 to 10 raised to 4, right, inclusive. So follow-up is, can you solve it using only one pass, and can you solve it in order of one space? So that one we will check later, but I'll first explain you the solution. So this is the example one, right? We will take and understand what the problem means. So this is the first example, right? So they have already identified the mountain array here, and they already identified the length of that mountain array is 5. So we'll just take that example over here. This is the input array that is given to us. So as you can see, the mountain array they identified is this one, right? This is the mountain array basically in this example. As you can see, 1, then 4, then 7. So it is increasing. After it reaches 7, this is the peak, and then it will decrease, right? 3 and 5, right? So this is the mountain array. So the length is 5 basically, right, for this mountain array. So that is what we have to identify, how to identify the mountain array, right? So now to solve this problem, we will use a dynamic programming approach here. So how we will use this DP approach is, we will create two types of DP's array, two type of DP array. So first let's understand a little bit of a logic before we start going into the DP array details. So as you might have already recognized now, so what we need to identify uh, if it's a mountain array is basically mountain array. For example, if we go here, right, mountain, this is the mountain array, right? So mountain array has a peak, right? This is the peak. So peak has couple of elements which are on the left side. For example, two elements are there, right? 7 is the peak, so 1 and 4 are two elements which are on the left side, correct? And then there are couple of elements on the right side of this peak, right? So now right side has a 3 and 2, right? So now this one is this logic we can use to solve this problem. How we can solve this problem is, if we prepare, like, we will do two passes basically, right? Two passes. How we will do it? Once in one pass we will go in this direction starting to end, and in another pass we will go from ending to start, right? And then we will populate two types of DP arrays, right? So now let's go in this first pass. Let's say this is our first DP array we want to populate, correct? So what we will do in that pass is, we want to identify for each element how many elements on the left are smaller than that element that will contribute to the mountain array, right? That will contribute to the mountain array. So now, for example, first element is 2. So are there any left side element? 0, right? So I'll just put 0 here. So now when I go to 1, are there any left side elements which are smaller than this, right? No, there are no elements which are smaller than this, right? So I'll put 0 here, right? Now I'll go to 4. Now are there any left side element which is smaller than this? So I'll check. Yes, 1 is smaller than 4, right? So I will put 1 here, right? Correct? And it means that I'll just add 1 to this element, right? I'll add 1 to this element basically. So 0 plus 1 is 1, correct? Now I will go to the next element, which is 7. I'll check if are there any left side elements that can contribute into my mountain. Yes, so I will ask that question to 4. So 4 is smaller than 7. Yes, right? So I will take this value 1 and I will add 1 to it. So it will become 2. Correct? So now I put 2 here. So what it means is there are two elements on the left side of 7 which can contribute into the mountain array, right? You can see that two elements are 4 and 1 which can contribute into my mountain array, right? Because they are smaller and they are in a like a descending way, right? 4 7, then descending is 4, and then descending is 1, right? So they are contributing to my mountain array, correct? So we are identifying elements on the left side in the first pass, right? Now when I reach 3, I'll check if it is smaller than 3. No, so I'll just put 0. When I go to 2, is it smaller than 2? No, I'll put 0. When I go to 5, is it smaller than 2? Yes, it is smaller than 2. I will put 1. I'll add 1 to this value, so it will become 1 here, correct? So now this way I have prepared the DP array. This DP array I prepared, right? So what this DP array is telling us? It is telling us let me just remove this color. It is telling us that for each of this element, for example, each of this element, how many elements can contribute into my mountain array on the left side, right? Left side, that is very important. I'll just write down here left side. So we have seen left side here, right? Now what we will do in the next one, we will see right side here, correct? Right side. So now for right side, we will go in this opposite direction, right? So I will start with this element. So I am at this element 5. I'll ask the question, is this next element like greater than 5? No. First thing is I'll put 0 here, right? Is it greater than 5? No. Then I'll check this too. Is this element sorry, the the next element that we are looking is this um, uh, basically what we are checking is if for this element is this smaller, basically, right? Smaller, let's just say. So what we are checking when we are going to the right side is we want to check if this next element that we are checking, is it basically bigger, right? Bigger than this element. So is it like, basically we wanted to check how many elements on the right side of this peak, right? This is the peak, so how many elements on the right side of the peak can contribute into our mountain array, right? So we have to check, actually when we are checking, then we have to check for each of the element how, like if this element has like let's say we are checking this element, then we will have to check if this is smaller than this, right? This element should be smaller than this, then we will add 1 to it, otherwise we will add 0. So we'll put 0 here because they will not be contributing to our mountain, right? Then when we are seeing 3, then 3 can contribute to our mountain, right? So 3 can contribute to our mountain, so we will add 1 for 3, basically, right? Means there are one number on the right side of 3 which can contribute into the mountain, correct? Then when we reach 7, we will ask 3, if 3 is smaller than 7, yes, then we have to add 1 to it, right? So we will add 1 to it, basically, correct? So what we are getting in this second DP array is we are getting number of elements which are on the right side of this number which can contribute into our mountain, right? So this is so I'll explain you one more time this one. So when we are going element by element, we will, for example, when we reach here, we will ask this next element here, right? If this element is basically contributing to that array, how many elements can contribute? So this element can contribute, right? Because this is smaller than 3, right? Now 5 is not smaller than 2, right? So we'll just put 0 here, 0 here, right? So by default for the last element we will put 0. Why? Because last element there is no right side element here, so we'll put 0. Now 5 is bigger than 2, so we will put 0 for that, right? Because it cannot contribute to mountain, right? For contributing to mountain on the right side, they should be decreasing order, right? So let me just show you. So mountain becomes like this, right? Mountain becomes like this. So this is our peak element. We have already seen the left side in our left array, right? Now we are seeing the right side elements. So when we are going in this direction, these numbers that we will see, let's say this number, then this number, then this number, they should be basically in a greater order, right? Ascending order, right? As you can see, 2, 3, 7, they are in ascending order, right? So which means that when we are checking the number, let's say when we are so you got the idea, right? So this is for the right side array. So when we are checking for 2, we will check this number, is it bigger than sorry, if it is bigger than 2, then we will if it should be smaller, basically, right? Smaller. For example, for 3, 2 is smaller, so we will contribute it, right? It will contribute to the answer, basically. It means we will add 1 here, right? So for 7, this right side is smaller, basically, right? So we will add 1 to it, so 1 to it, so it will become 2, correct? So it means that we have 2 elements on the right side that can contribute into the mountain array. 5 cannot contribute into mountain array because it is bigger than 2, right? So the mountain array will look like this 7 for example, then 3 and then 2, right? If I plot on the graph, right, this is the right side of the mountain, right? This 5 will be bigger than 2, so it will not contribute into the mountain, correct? And then this remaining 4 cannot contribute because this 7 is greater than 4, right? So it will just put 0. 4 is greater than 1, right? We'll put 0, right? Then for 2, 1 is greater than 2, so we'll put 1 here, right? So this way we have now created two DP arrays. One is left array and one is right array. So now I hope it is clear to you. So I'll just remove all this coloring. So now this is our left array that we created. This is our right array. So what left array tells us, for every number how many elements are there on the left side that are contributing into our mountain array. For example, when I see 2, this is 2 is corresponding to 7, right? 2 is corresponding to 7. It means that I have two elements on the left that are contributing into my mountain array. That's why 2 is there. Now on the right side again I have 2 for 7. It means that I have two elements on the right side of 7 that are contributing into my mountain array. These two, correct? So if I want to identify the length of my mountain array, how I will identify? I'll just put 2 plus 2 plus 1, right? Why I added 1? Because to get the total length, this is 2, this is 2, and I have to add this 1 for this peak itself. The peak element has a length 1, correct? So total length is 5, right? So this is how we will identify the length of the mountain, right? And we will go through this whole 2 DP arrays and we will keep adding these values, right? Like 2 plus 2 plus 1, 5, like this, right? And then we'll keep track of the maximum. So the maximum value will give us the longest mountain in the array, correct? So you got the idea, I hope. So I'll show you one other example that I created. This is a little bigger example that we have seen here. This is the same example. We have two mountains here. One is 5, one is 7. So we have to choose the maximum. So how we will choose it here? For example, we will this one is our 5, right? This one we will add 2 plus 2 plus 1. So it will give us 5, right? But when we look at this position, it will give us 3 plus 3 plus 1, it will give us 7, right? Because 20, for 20 peak we will get 3 elements on the left side, we will get 3 elements on the right side. So this is the maximum, so we will return maximum. So you got the idea how our DP solution will work. So I am going to show you now the Java solution for this problem. With examples it becomes a lot easier to understand, right? Otherwise it becomes tricky. So now this is our longest mountain method we are implementing. It returns integer because we want to return the maximum length of the mountain array, right? So A is the array that's given to us. We will just calculate the n, which is total numbers in the array. If n is 0, then we will directly return 0, right? So that's straightforward. Now we will create two arrays here, dp and dp1 of length n, right? Length n we will create. After that, what we are going to do here is we are going from left to right. We are going, right? So this is what, as I explained you, we are going from left to right. So let me just remove all this. So first step we are doing is we are going from left to right and we are populating this dp array, correct? So as you can see, if I is 0, then directly we will put 0 for the first element, right? Because there are no other element on the left side of the first element, right? Otherwise we will check if the array of I is greater than I minus 1, right? Then we are going to add 1 to the previous value, right? Because it is going to contribute one more element into our length, correct? If this is not the case, then we will directly put 0, correct? As I shown you in the example. For example, when we go here, we directly put 0 because the next element, the previous element is actually bigger than this. When we go to 4, we'll check the previous element is smaller, so we will put 1 to this. We'll put 1 to this, right? So it becomes 1. Again, this is smaller, so we'll put 1 to this, so it becomes 2, correct? So that's what we are doing here, right, in this for loop. So our dp array will be populated, correct? And I just wrote in the comment what it does, right? So basically it's counting how many numbers are smaller than ith DP element on the left side that can contribute into our mountain array, right? So as I explained you in the example. So we have populated our DP array now in this for loop. We will do again one more for loop, right? And what we are going to do in this second for loop, now we are going to go in opposite direction in the second for loop. So we will go in this direction now. So we will start from this element. So this element 0 directly, right? Because there is no element on the right side of this element that can contribute into the mountain array, right? So we are now populating DP1 array in this next for loop right here. So as you can see, we started at the end, we are going towards 0. And what we are trying to find out, we are trying to find out for every element how many numbers on the right side can contribute into our mountain array, right? So for the last element, we'll directly put 0, right? Because there are no elements on the right side of the last element, right? Now here we are checking if AI is greater than AI plus 1, right? So AI, this one, let's say for example this one, right? AI is greater than I plus 1. So sorry, so this is I and this is I plus 1, right? So if it is greater, right, AI is greater than I plus 1, no, so we'll put 0. Now when we reach here, AI, is it greater than I plus 1? AI is greater than I plus 1, yes, so we will put 1, right? AI, this one, is greater than I plus 1, yes, so we will add 1 to it, right? So like this. So we will put 1 to it because that is going to contribute in our mountain array, right? If it's not contributing, we will just put 0 basically, correct? So this is the way we will populate our DP1 array now, right? So this one is a DP1 element basically, right? And this is a DP1 array that we are populating. So our DP and DP1 both arrays are now populated. So it will look like this after populating arrays, right? After that we will go and we will sum these corresponding elements 0 plus 1, 1 plus 1, 2, like this, right? So when we reach here we will get 5. So we will keep track of the maximum that we are seeing, right? That will give us the maximum or longest mountain length, correct? So as you can see, we are going 0 to n. If dpi is not 0 and I plus 1 is not 0, which means that these elements are going to contribute into our mountain array, right? It should not be 0 basically, then only we will consider, right? Then what we do in that case, we take dp of I plus dp1 of I plus 1 we are adding, because we want to consider that element itself, and we will keep track of the maximum in result and we will return result that will give us the longest length, correct? So this is the approach. So let's go ahead and test this solution with this same example that I created. This is the same example we saw here, right? So 7 should be the answer we are expecting. So we are getting 7, which is the correct answer. Let's check out their test cases. So let's just do this first test case. So this should give us 5. So we are getting 5, which is the correct answer. Why 5? Because this is the mountain, right? 14732, maximum length 5. So let's take all the examples and run in one go and make sure everything passes. Then we'll submit our solution. So 50, we are getting correct answer. So we'll submit our longest mountain in array DP solution now. So our solution got accepted by Leetcode. It is 69% faster than other submissions which are done online, and it is 5% faster on the memory usage. So this way we can solve these important coding questions, which was a Facebook, Microsoft, Google coding question. So let's talk about the time and space complexity for this one, right? So let's talk first time complexity. So now we have these for loops, right? This is one for loop, this is another for loop, and this is another for loop. So all are order of n, right? Because they are separate than each other. So it means that the time complexity for this solution will be order of n, correct? That is the time complexity. So I'll just write down for you here. So time complexity is order of n, correct? Because we have to go through all the n elements, right? And now space complexity, right? Space complexity for this solution is again order of n. Why it is order of n? Because we need these two DP arrays that will store n elements, right? So essentially it is a 2n, but we don't count 2 into the explanation, right? We ignore that constant when we are explaining the space complexity. So basically it is on. So I hope you understood the time and space complexity for this solution. If you are new to my channel, there is a dedicated playlist for Leetcode problems on my channel. It has more than 250 different varieties of problems solved and explained using whiteboarding session examples and Java code. For all the videos, the Java solutions are available in my GitHub project, and links are always shared in the video description, where you can go and check out the Java solutions. You can play with the Java solutions for your more understanding. If you like this video, if you find this video helpful, and if you like the way the video is created with these examples using whiteboarding sessions for your easier understanding, then please give it a thumbs up to the video, give it a like to the video, subscribe to the channel. Your subscription is very important for the channel, because that is the way the videos can reach to more people who need help in solving coding problems. Some people find it difficult to solve coding problems. So in this channel, we wanted to help them by showing and demonstrating them how different coding problems can be approached, how logic can be built to solve those problems using different techniques, different data structures and Java. So if you like this video, give it a like, share it as much as you can with your friends, colleagues and other people you know. So they can also come to know about the video. They can also watch these videos, and they can also learn about more computer science programming, problem solving using different data structures and Java. To become more and more confident in your coding rounds of interviews, you should practice different varieties of problems. Try to use different techniques, try to use different data structures, and implement your code in different languages, including Java. That will boost your confidence in your coding rounds of interviews. For in-person interviews, make sure you do some practice of whiteboarding sessions. This is very important for in-person interviews, because your communication skills matters a lot there. It's very important how well you can explain your solution to others in an easier and better way, and how well you can go step by step so others can understand it. So make sure you do that practice. That will definitely help you in your in-person rounds of interviews. If these videos on this channel and if the tips we share, if they are helping you, then please write in the comments of the video, so we'll come to know about it. This is important for us to know how the videos that we create are helping others, and that also motivates us to create more such good quality content so others can benefit from it in their interview process. So please write in the comments how the videos are helping you. Also, whenever we see any important problems, we solve those problems and post the videos on this channel, so others can also understand how to solve those problems, and they can also benefit in their interview process. So make sure you click on the bell notification icon right away, so you will immediately get notified as soon as we create new postings here. Keep learning, keep coding, and keep solving different varieties of problems, and thanks for watching these videos.